Machines. Machines are the things which make our work easier. There are a lot of functions for machines. Some of the functions are force multiplier, change in the direction of effort, and gain in speed. Change in the direction of effort means it is the change in the direction of effort to a convenient direction. So these are the functions of machines: force multiplier, change in the direction of effort, and gain in speed. We have to be familiar with some technical terms: load and effort. Load is something which we have to overcome with a force. So it is also a kind of force. That it is a kind of output force, and the effort is the force which we are giving to something with the help of a machine. So that is an input force, and both are a kind of force. So it is expressed in Newton or in kilogram force. Load and effort. There is another term called mechanical advantage. Mechanical advantage is the ratio of load to the effort. And from the value of mechanical advantage, we can find out the function of that particular machine. If the mechanical advantage is greater than 1, that means effort is very much less than the load, then that machine act as a force multiplier. Very much lesser is given to overcome a load. If the mechanical advantage is equal to 1, that means load is equal to effort. If 5 Newton load and 5 Newton effort is given, then the value of mechanical advantage is equal to 1. But in that case, the machine can use to change in the direction, the effort to a convenient direction. If the mechanical advantage is less than 1, then more effort should be given to the load. So the denominator in this case is more and load is less, numerator is less. So mechanical advantage is less than 1, it acts as a speed multiplier. So if the mechanical advantage is greater than 1, the machine acts as a force multiplier. Is equal to 1, it is used to change in the direction, and if it is less than 1, it is used as a speed multiplier or in gain in speed. There is another term called velocity ratio. So if we use a machine to something, then sometimes the load or the effort moves. So the first equation for velocity ratio is velocity of the effort to the velocity of the load, and the second equation for velocity ratio is the displacement of the effort to the displacement of the load. Load and the displacement may move. So both denominator and numerator has same force, so there will be no unit. From the value of velocity ratio also we can find out the function of that particular machine, like in the case of mechanical advantage. If the velocity ratio is equal to 1, the machine acts as a force multiplier. If it is equal to 1, change in the direction, and if it is less than 1, then speed multiplier. Next is efficiency of a machine. Efficiency of the machine is work output by work input. Work output means that is in the case of the load and the displacement. What is the equation for work? Force into displacement. Here force is load and the displacement is the distance or the displacement of the load. And work input is effort and dE. That is, input means the force given by us. That is effort. Effort is from our side. And the efficiency is always expressed in percentage. So efficiency is equal to work output by work input. Output is in the case of a load and work input is in the case of the effort. So force into displacement, instead of force, L into dl. dl is the displacement of the load, and E into dE, effort into displacement of the effort. What is L divided by E? It is none other than mechanical advantage. Then what is dE by dl? That is velocity ratio. We have already learned about that. So dl by dE is the reciprocal of velocity ratio. Therefore, efficiency eta